All right, so if we want to talk about the Pythagorean theorem, which is 3.1 in our course pack, then we're going to have to start talking about some right triangles. And so a right triangle, first of all, is a triangle that has a 90-degree angle. So this mark right here, this little square in the corner, and I think we've discussed this before in some of our drawings and some of our activities, but that is a right angle. And a right angle is a 90-degree angle. So anytime we have a little mark like that in any sort of a geometric figure, that represents a right angle. So we're going to talk about the Pythagorean theorem, which relates the three sides in a right triangle. And I snagged this little picture of Pythagoras himself. Not really a picture, actually. I don't think cameras were around back in Pythagoras's day. But I did snag this little picture so we could have a little image of Pythagoras while we talk about his famous theorem, the Pythagorean theorem. So the Pythagorean theorem relates the three sides in a right triangle. And so this is what it states in words over here, and then the formula right below it. But I do want to talk about it. So the sum of the squares of the two short sides. So anytime we have a right triangle, the two shorter sides, or the two sides that define make up excuse me, the right angle, are what we call the legs. So this is a leg of the triangle, and this is a leg of the triangle. And then the side that is opposite, and you can think of that as this side right here. So the side that is opposite the right angle is called the hypotenuse. So regardless of how we actually draw our right triangles, that is how we will always define the two short sides. They'll be called the legs and the hypotenuse. And for the Pythagorean theorem, we define the two legs as A and B. And then the hypotenuse is the longest side of the right triangle directly across from the 90-degree. So if I were to draw a right triangle like this triangle here, okay, then this would be called a leg, this would be defined as a leg, and this would be the hypotenuse, HYP for short. And if I were to draw a different one, like for instance, let's make one that looks like that. In that triangle, these two short sides would be called the legs that make up the 90-degree, and then directly across from the 90-degree is called the hypotenuse. Okay, so that's the first thing. When we're going to use a theorem, we got to make sure that we've correctly labeled the figure that we're using. So each of these legs in all of these triangles we're going to define as A and B, and the hypotenuse as C for the Pythagorean theorem. So that would make these two legs A and B, and the hypotenuse C. Now, just to be clear on this real quick, the way I labeled A and B, I could have flip-flopped these. So right here I've got in this particular triangle right here, I called this leg, the shortest side of this triangle, A, and the longer of the two short sides, B. But I could have flip-flopped those. That doesn't matter when you're labeling the legs, which one you label as A and which one you label as B, as long as you have the hypotenuse labeled as C. So it might be best to label the hypotenuse first. So then the Pythagorean theorem says this. It says that the sum of the two squares, the two legs squared, a squared plus b squared, the two short sides, a squared plus b squared, has to be equal to the hypotenuse squared, c squared. So I actually tend to like to write this in this way. So for the Pythagorean theorem, you can say a squared plus b squared equals c squared based on how we've labeled it. But I actually like to write it sometimes as just leg squared plus leg squared equals hypotenuse squared. Okay? And that's the Pythagorean theorem. That's all the new content. I just want to run through a couple examples. If the content is a little longer, I would normally make that one video and do examples separately. But since the Pythagorean theorem has just this one statement of this formula, let's just go ahead and jump right into a couple of examples. So I'm going to leave that. Actually, we better put a little picture with that too. So if we've got that, a squared plus b squared equals c squared, I'll draw my little picture here real quick just to follow up. Just one more right triangle, label it. This would be our A, our B, and our C, because this is a leg, and this is the hypotenuse. Okay, So let's do an example. So let's just suppose that we had a ladder. So let's, example 1. Suppose that we had a ladder and it was leaning up against a building. So here's our building, and went a little bit too low to the ground. So let's do, we've got some building here, and let's suppose this ladder was 10 feet long, and we laid it at a length right here of 8 feet from the base of the building. And we wanted to know how far, if I do that, how far up the building will it reach? So a 10-foot ladder placed 8 feet from a building. Okay, how far up the building will it reach? Well, the first thing we're going to do is we just need to label. So the two shorter sides, the two sides that make up the 90-degree angle, are the legs. So this is a leg and this is a leg, making this side across from the 90-degree and the longest side the hypotenuse. So we've got two legs and the hypotenuse. So for the Pythagorean theorem, we know that A is 8 feet. I could have easily labeled that B. I just went for A. The unknown is our other, A or B. In this case, since I started with A for the 8 feet, then the unknown leg is B. And then the hypotenuse is C. So let's make sure that we always label our triangles. So we make sure we've got our two legs in the right spot and the hypotenuse defined correctly. And now we can go right into the Pythagorean theorem. The Pythagorean theorem says that a squared plus b squared equals c squared. So I can plug those in. So 8 squared plus, well, we don't know what b is, so b squared equals 10 squared. And now I'm back into chapter 2 where I'm trying to solve an equation for an unknown value. So if I want to find b, the first thing I would probably do before I start moving anything around, undoing any operations, let's go ahead and do the simplification. So 8 squared is 64, plus b squared equals, and then 10 squared is 100. And then we'll do the simplification. We've done the simplification, so now we can start solving for b. So since I have an addition right here, I'm going to use a subtraction, minus 64 from both sides, so that I can isolate b, and then I'm going to get b squared equals, and in this case, I kind of cooked this problem up so it would work out kind of nicely without a calculator. B squared equals 36 here, and then to undo, so remember to undo an exponent, we use a root, and since it's a square, we'll use a square root. So we'll take the square root of both sides, and it turns out that B is actually 6, and it's going to be 6 feet. So that ladder would reach 6 feet up the building if it was placed, as we had shown up there, if it was placed 8 feet from the base of the building. A 10-foot ladder would reach 6 feet up the building. Okay, so there's our first example. So let's look at another one. Okay. So let's suppose, so example 2. So let's suppose we were laying out a rectangular, I don't know, a garden or a rectangular concrete pad, and we wanted to know that out a little bit more. We wanted to know what the diagonal would be, so let's call this D. Suppose we wanted to know what the diagonal would be if this length right here was, let's say it was 11 feet 7 inches, and this width right here was, let's say, 8 feet and 3 inches. Okay? And we wanted to know what is the diagonal of this rectangular pad. So I'm not going to write it out in words. I said it, and just to save a little time on the video, I won't write out in words. But if we had a rectangular pad with a length of 11 feet 7 inches and a width of 8 feet 3 inches, what would be the diagonal? So what would be the diagonal going across that pad? Okay. And so what we're looking at here is, again, a right triangle where the two sides that make up the right angle are the legs, and the longer side is the hypotenuse. So when we're doing this, we can start by labeling, okay, so this is going to have to be A. This is going to be B. And again, I could have flipped those. I could have called 11 feet 7 inches B and 8 feet 3 inches A, as long as the two legs are labeled A and B, and the hypotenuse, on the other hand, has to be equal to C. Now, in this particular case, it already had a variable. It was given the letter D. So as long as we are calling it the hypotenuse and remembering that it is leg squared plus leg squared equals hypotenuse squared. Okay, so before I can jump into this formula, though, I've got mixed units. So this is a little review back from, I got to grab my calculator here. It's a little review back from the section, I think it was 1.4, where we were doing conversions. So we can't have mixed units if we're going to be plugging into a formula. So let's convert these units into either all feet or all inches. Sorry, I don't know what that was. All feet or all inches. And so in this particular case, if we were in a classroom, I would ask you guys and we would just poll the class, what do you want to do, feet or inches? But since I have nobody to poll but myself, I'm going to go ahead and go for inches. So let's go ahead and go into all inches. And to do that, I have to look at each of the feet. So I'm going to take the 8 feet and I'm going to multiply that by 12 feet. I'm sorry, 12, not 12 feet, 12 inches per 1 foot. And then I'm going to add the 3 inches that we already have. And I'm going to just go ahead and write this as feet. So I'm going to take the 8 feet, quick little conversion here, going to turn the whole number of feet, which was 8 feet, into inches, and then add that extra 3 inches. So converting this just into all inches here. And so the 8 feet times 12 plus 3, I'm going to do that on my calculator here, 8 times 12 plus 3, that gives me a total on this side of 99 inches. And then I'm going to do a similar calculation here on the 11 feet 7 inches. So I'm going to take the 11 feet, I'm going to multiply it by 12 inches in every 1 foot to convert that piece into inches, and then add the remaining 7 inches. And so what we get on that side, 11 times 12 plus 7, again, just jump into the calculator here, 139 inches. So my A is going to be 139 and my B is 99 inches. Okay. Okay, so now I can plug that into the Pythagorean theorem. So now we're going to go to A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared. So we can go to that piece and we can plug in 139 squared plus 99 squared equals, now we could say C for the hypotenuse, but it was labeled on the diagram as D, so I'm going to write D squared. All right. Now again, before I try to solve for anything, before I undo any operations, I'm going to go ahead and simplify. So 139 squared, I'm going to the calculator again, 139 squared plus 99 squared. It's far easier when you guys are in the classroom and I can ask you to do the calculator work. So this is 29122. So 29,122 equals D squared. And then to undo that square, I'm going to take the square root of both sides. And again, going to the calculator, square root of my answer from before, and I end up finding that D is approximately 170.652. Okay, so that's what my value of D is. Now remember, I've converted all my measurements into inches, so then this is actually going to be in inches. And let's do a couple things here. First of all, let's do this to the 16th of an inch. So what if we wanted to do this to the 16th of an inch? Just a little bit of practice on all our concepts here. So if I wanted to do that to the 16th of an inch, so what would that be? It's going to be 170 and some amount of 16ths of an inch. So I'm going to take the 0.652 and I'm going to multiply that by 16 over here on my calculator, and that comes out as 10.432, but rounded to a whole number, that would be 10. which would be equal to 170 5/8 of an inch would be my answer in inches. Okay, so what if I also wanted to, right? So that's how we could do it to the 16th of an inch. What if I wanted to convert back to essentially, remember we started off with a mixed unit. We had feet and inches. So what if I wanted to convert back into feet and inches? So let's go back to D equals 170.652 inches. Okay, so and we can do whole inches on this one. So we'll do a different, just a different little way to represent our answer. So whole inches. So if we were asked to put our answer back into mixed units, feet and inches. So how could we do that? So it's a bit of an extension off of this problem. So if we had our final answer, 170.652 inches, how could we convert that back into those mixed units of feet and inches? So, well, this is just going back into conversion. So we would have, if we had 170.652 inches, if I wanted to figure out how many whole feet that is, well, I would multiply by 12 inches on the bottom, 1 feet on the top. So basically dividing by the inches now, because now we're going backwards, going back. The inches would cancel. And when I do that, when I take 170.652 and I divide by 12 or multiply by 1 over 12, I end up getting 14.221 feet. Okay, so now that's an answer in all feet, but I actually wanted mixed units. But here's the thing. I know now that there are 14 whole feet, so I can say 14 feet. What I need to figure out is how many leftover inches are there. Okay, and so this is kind of like we do with the 16th of an inch, and we've done it with the 32nd of an inch, an 1/8 of an inch. We've done this before. So we're going to look at what was left over, that 0.22, and the 0.22 is in feet, 221. So the 0.22 there is in feet. So if I just multiply that by 12 inches for 1 foot, I will figure out that this is approximately, so take the 0.221 times 12, that ends up being approximately 2.652 inches, but we can go ahead and round to a whole inch. So that is approximately 3 inches remained. So we ended up with 14 whole feet, and we can now say, erase that question mark and say 14 whole feet and 3 inches. So as a mixed unit, we could say 14 feet, 3 inches for the diagonal. Okay. So I wanted to show you guys how we could write our answer in a couple of different ways. So here's writing it, converting it into mixed units again. So converting it back from the full inch measurement that we had gotten, converting that measurement into mixed units again, feet and inches. Or sometimes we're asked to take our answer and convert it into something like the 16th of an inch. And so that was doing it to the 16th of an inch. And this was doing it in mixed units here. Okay. All right, so just a couple of different ways to represent our answer and a couple of examples just on Pythagorean theorem. I'm going to make 1 or 2 more examples with a couple more Pythagorean theorem, a little more advanced, where we use a few more concepts. But I wanted to have this video with just a couple of basic examples so you guys can get started working on the homework and taking a look at 3.1.